Alright, we're going to do two more recursive functions today. The first one is just sort of an easy list one that it's called list fill, and it actually makes a list and fills it up with a certain item. So we give it a an item, and then we give it a length that we want the list to be, so like 5, and that would give us a list of length 5 with 5 A's in it. A. Oops. Alright, so how are we going to make this? We're going to have to count down the 5 till it gets to 0. And what are we going to do at 0? We'll make list fill. Let's just see here. List fill A 0. What would that be? That would be a list with 0 A's in it in length of 0, so that would be that. So naturally then we can define this where our base case for list fill lambda item lang. That sounds for length if you don't know. Alright, so if 0 len, then we're just going to return an empty list. So if we have an empty list at the end, we want to be filling it up with a bunch of A's, or whatever the item is. So we're going to cons the item into what here? List fill. Into the list fill of the same item, but subtracted 1 from length. That's it. So first it'll be let's say list fill of A of 5. First it'll be like well, hold on. List fill A of 5 equals cons A into the list fill A of 4. Let's just do this like list fill of 2. That'll be a little bit faster for us to show you. Alright, so list fill A of 1, which equals, just put this down the next line, that equals cons A to the cons cons A into the list fill A0. And we know list fill A0 is just the empty list, so we get cons A into cons A into the empty list, and that will give us a list of 2 A's. So let's try it out. Run. See, list fill A2. There we go. Just fill. Now we could also do like make this a list. We'll fill up a list with like 6 copies of that. See? It's pretty nifty. You can pretty much put anything you want in there. We could even do this. List fill A2. I'll put that 6 times. That's pretty nifty, isn't it? Alright, now let's get on and do a little bit more difficult function called increasing, and that it's a predicate increasing with a question mark, and it just returns true if the list is increasing in magnitude of numbers. So like this one would return false because the 4 is less than 8, so that will be false. And increasing 1, 2, 3 of course would be, well, and this doesn't have to be one after the other. We could do like 1 to 88, and that will be true. Alright, so let's do kind of the base cases. Increasing when there's just like an empty list. That, I mean, it's not false, they're not decreasing, so we just say it's true. Alright, and let's do increasing of just like one element. That It's not decreasing, so we'll just say it is increasing. True. Alright, then so those are the base cases. And for anything else increasing, say there's just like 2 items in there, 1 and 5, then we'll just check is the first one shorter than, smaller than the second one in the list. So the car of the list shorter than the car of the coulda of the list. And if that's true, then we'll return well, on this one, obviously, if it's true, you can just return true. But let's say there's like a third number in here, say like 8. Okay, so if 1 and 5 is greater than 1, then that part is true. So then we have to check and see if 8 is greater than 5. And how do you check if 2 things are greater than each other? Well, you can just run increasing on the rest of the list. So first we check these 2 numbers. If that's true, then you call increasing on the coulda of the list. Okay, so now that we've gone over all the cases that we might want to do. And if this is false, like 51 and 5, then we can just return false right away. We don't have to call increasing anymore. Now if we just keep going through the list calling increasing, when is it going to return true? Well, it will return true when there's only 1 element left in the list, or if it goes to the empty list through some magic. Alright, define increasing lambda ls. Okay, let's see here then. We'll do a cond since there's so many cases. Cond null ls. Then we'll return true. Now you want to check for null first, because if you check for if there's only 1 element in the list by seeing if there's a car, if the coulda is null, then it might give you an error because it's trying to look up the coulda on an empty list. So you check the regular, if the list is null first. Alright, then null coulda ls. I'll return true. Else, oh yes, okay. So let's say if it's false, then that would be if the car of ls is greater than the cadder of ls. How do you greater than car ls cadder ls. Okay, then we're going to return false because that means it's not really increasing. Alright, then else means that well, I wonder. Okay, so I guess we'll make this so that it is greater than or equal, like if you did this 2 2, that would be okay. We'll say that's okay. So if they're equal to each other, that's fine. So that's handled in else, yeah. Okay, so else will do increasing on the coulda ls. And so if it just keeps couldaing on down the list until it gets to 1 item left, then we'll know it's an increasing list. Oh bother. Get rid of all that. Let's run it. See, increasing 1 2 3. True. Okay, good. Increasing false, because it gets to there and realizes no, that's not increasing, and then it's false. And if you'd like to, we can trace it in Petit's scheme. Alright, trace increasing. Okay, then what was our command here? So we'll trace that, put it in there. Yep, so it calls it on that full list. It cutters on down till it gets there. I compared those two, and it said no, that 23,123 is less than 234,355. So that is obviously not true. Alright, well, I hope you understood those two functions.